One sec. I need to figure out the bottle situation. Okay, hi. Excited to be here. My name is Dan Abramov. I work as a software engineer at Bluesky. We're building composable, open source social media, so check it out if you're into that kind of thing. But my talk is not about Bluesky. My talk is about React, and it's called React for Two Computers. The first thing you should know about this talk is that this is a talk. Sure. It wasn't supposed to be a talk, so I thought that this would be a blog post. And I tried to write this blog post maybe like 13 times. I have a bunch of drafts that I never published. And I just couldn't quite figure out how to do it. And I realized later that it's just because this is just a different format. And actually, it makes more sense as a talk. So how is a talk different from a blog post? Well, a talk is a performance. So I'm standing here, I'm in front of you, I'm speaking things, doing things. I might mess it up. I'm a little bit nervous. But it's some kind of like live action. And there are things you can do in a performance that are hard to do in writing. But a talk is not just a performance. A talk is also a story. So I wrote some kind of a story, and I came here with this story. And so this is the thing that I'm presenting. So you could say that in a way, this talk is kind of like a collaboration between two people. So there's me, who's presenting right now here at the stage, given this performance. But there's also the past me, who has written this talk and the story for it. And me and the past me, we're never in the same room. Like we're kind of separated by time and space. Like the past me is somewhere in London, trying to figure out like what to write about, and the present me is here. But there is a kind of communication between the past me and the present me. So the past me has written a certain script for this talk, and the present me is using the script to kind of finish the performance, and then the talk is not ready until both of the stages are done. Sure. So this kind of relationship between past me and me, it's kind of similar to, there are like other kind of patterns of human relationships that follow the same structure. So one similar relationship is between the scriptwriter and the cast of actors. So if like the scriptwriter is working on like a TV show or a movie, or like a playwright for theater, like they write a play, and then that is the first phase of the process. But then the play isn't really played until the actors actually embody the story and like bring it to life and then connect to the audience. So it's kind of like a two-step process where the author and the actors communicate in one direction through text or some kind of a script. So this pattern exists in human relationships, but it also exists in computer relationships. If that is a concept. So the pattern I want to talk about today is like the relationship between the server and the client. And there are different kinds of servers and clients. People mean very different things by it. So I just mean server and client as not even necessarily machines, more like computer programs. In kind of context of like traditional web development request-response model. So the client requests some page from the server, and then the server responds with something that the other computer should execute. So some kind of HTML and maybe some scripts within this HTML. And maybe if you think like of the word script a bit more metaphorically, like HTML is also kind of a script, right? Like it's like a programming language for what the computer should display. So the whole thing is kind of like a script. And so I want to dig into this a little bit, into this relationship. And so I've prepared a little example. So as everyone knows, the naming of cats is a difficult matter. So sometimes you need an app for that. So I built a little app. In case you need to name your cat, you just press. It already picks. It already picked the name for me. So I just press reveal, and I see. This is the name that is chosen for my cat. And the way this works is that there's an array, kind of hard-coded array of cat names, and I pick a random index from that array, and I take that cat name and display it in the document body. And so this is fine, but sometimes I don't really want to hard code, like let's say I don't want to hard code the list of cat names right here, because I want to have some kind of flexibility. So I want to be able to maybe fetch it from the database or read it from a file system, maybe ask ChatGPT. I don't know, like I want to have some kind of flexibility not to hard code the data that my application needs directly in my application. And so the way I would usually solve this is pretty traditionally, I would have some kind of an API. So I'm gonna do like await fetch. I've already prepared an API called cat names, and I'm gonna get the JSON from that API, and I'm gonna read the cat names from that JSON. And so let's see what happens. I'm gonna refresh the page. Oh, I see there's an error. It says await is only valid in async functions. So yeah, I need to make this function asynchronous. So let's refresh again and press reveal, and it works. Yay! I didn't break anything. That's a milestone. So yeah, this works. Ship it. I can go now. But there is a little bit of a problem that I actually changed the behavior quite a little bit here, because now if I load the page, and let's say that my connection goes slow, so I'm gonna throttle it, and then I press reveal, it's not instantaneous anymore. Like it takes some time to load because the data doesn't exist at the time the user interface is rendered. Like now I have to go get it from the API and wait for the response. And so maybe if I load the page and then my connection goes out, it will not appear at all. And in some cases, this is actually fine. In a lot of cases, this is fine because, for example, like if you click a link or you navigate to another tab, you kind of expect that, well, we're going to the server, like we're navigating, so we need to, fetch some information. So you expect some kind of a delay. Or if you're mutating some data, so like if you're saving settings or submitting a post or liking a picture or whatever, like you kind of expect, well, it's normal for these kinds of things to take time. But then we also want to have this kind of control over our user interfaces where we want to be able to say this particular interaction has to be synchronous. Like I want the data to already be there with that screen. I don't want to wait for it to kind of come later. Like I want to be able to ensure low latency for specific interactions. So how do we fix this? Any ideas? So it's kind of like not obvious how to approach this problem if you look from the client-centric perspective, because well, this is all I got, right? I have this fetch call, have to await it. There's not much I can do there. So maybe one thing we can do is we can look at the server code. So this is my server. You can see there is an NPI endpoint that I created that reads from a file. This is my list of cat names, and just returns the JSON. But if I keep scrolling down, there's something interesting here. So there is a script tag here that says, here's the client code for this page, which points to this code. And just to kind of make it more visually obvious what is really happening in our program and how our program is really structured, I'm just going to copy and paste this. So I'm going to put the code of this client code inline into the script. So that's not necessarily like the best way to write production code, and there are more kind of efficient ways to do this. But for illustrative purposes, I think it really helps kind of explain what's going on in the code. And let's just refresh to verify that, yeah, the code still works. And so previously, I was looking at the server code and the client code as kind of two separate programs that talk to each other. They kind of pass messages to each other or like request stuff from each other. But now I'm kind of looking at it from a different perspective. So I kind of look at it as a single program that spans two different devices, that spans two different computers. It's like a program that's evaluated kind of in two steps. And now that I start looking at this code this way, I start spotting some like optimization opportunities and just opportunities to simplify it that I wouldn't have noticed otherwise. For example, again, we want to make this function synchronous. We want to make the click handler synchronous. So I'm going to remove this async, but I have these awaits, right? Like I gotta put them somewhere. Well, you know, in React, there's like this thing you sometimes do, which is called lift and state up, where you put the state into a parent component and then you pass it down. What if we could lift data up, and instead of lifting it to a parent component, we lift it up to a parent computer. So we'll lift it up to the server. So I'm going to just copy and paste this from here. I'm going to put it here. Interesting, it also became colorful. It was all green before. This, you know, this like green font just like reminds me of the, you know, the Matrix movie, where you can just like see, like when you're inside, you think this is the real world, but actually, like no, like this is the real world. You're on the server. Okay, so let's see if this worked. Bam, it doesn't work. Well, it doesn't work because I need to, now that this fetch is happening on the server, I need to actually specify, you know, what the host is, because it can't guess it, I guess. And so if I press reveal again, it doesn't work because it says reference error, JSON is not defined. So if we look here on the page, of course, I'm using this JSON variable, but it's actually defined here. And you know, if this was a regular kind of nested function, that would just work, right? Like that's just a closure. But what we're trying to do here is more like a closure over the network. That's weird. How do we make this work? Well, one way we could do this is, you know, what is the purpose of JSON? Like that's the stuff that you can send over the network. So this is a program that sends another program as a piece of text, as a string. So we can turn this JSON into a string in order to send it together with our program. So I'm going to call json.stringify. Yay, it works. And notice something interesting now is I load the page and I press reveal, and there is no network request. And the reason there's no network request is because, well, the data is already there. It's already on the page. So this is kind of an interesting way to think about client and server, and I'm just going to continue down this rabbit hole and see where it leads me. So the other thing I'm noticing is, okay, like when we hit the server and we want to serve this page, and the first thing that happens is that we call the API, but where does that happen? Well, we hit the same server that serves this API, it returns to JSON, and it returns it like this. And I'm like, do I really need an API for this? Like maybe in some cases, but probably not in this case, because I only have one usage. So I'm just going to paste this code here, and I'm going to delete this API handler. Let's verify that it still works. And you could say maybe, what about abstraction? Like, what about separation of concerns? But I can always, like, if I don't want to have this code in line here, I could always pull it into another file. I could put it into a module. I could give it a name. The API was not really enforcing separation of concerns or anything like this. So we still have tools to do this, and we can still extract this thing if we really want to do that. All right. I forgot what I'm supposed to do next. All right. So there's another thing we'll notice if we look at the response. So what's happening right now is that the list of cat names is inlined in JSON, but it's actually pretty long. But now that we have like a whole picture of what's really happening, including both the server and the client side, we also kind of see the relationship between like how the data flows from the API into the component, like into the client code and how it's being used there. So I noticed that the cat names from here flows here, and then I select a random one from them. And I really only need one of them, so it doesn't make sense to send all of them. So maybe I'll just take these lines, and I'll actually move them up, and I'll extract them. I'll put them here. So this is something I can do ahead of time on this computer, and I can pass the cat name instead through JSON. And so now if I refresh the page, and I press reveal, it still works. But if I look at the data inlined on the page, it is only data for this one single thing. And so I want to kind of like take, I've done a bunch of changes to this file. I kind of turned it inside out a little bit. And so I want to take a look at the result, like what is the shape of this thing. And you could say it's pretty messy. Like I think like that's one possible reaction is, oh, this looks like some code I wrote in like 2003 with like PHP and interpolating strings and just like passing things, kind of like a mad scientist. But if you're kind of functionally brained, like maybe you'll think of this as, oh, this is kind of like partial application of the network. There's this concept of applying a function in like several steps. And this is kind of like this, except that there's also like a network step in between, which is kind of interesting. But I think the main way I kind of look at this is that we've removed all the boundaries that are inessential to the problem. We've removed all the boundaries that we can remove, and the boundaries we're left with are just dictated by the laws of physics. So this code executes first, like it has to execute on this computer, and then it emits this code that will have to be sent to another computer, and it will execute later. And then we can pass some data together with this code. So that is really the fundamental shape of the problem. No matter like which library you're using, which approach you're using, it's going to kind of look like this, like when you strip it down. So there are these like two different worlds. Like this code executes in one world, and this code executes in another world. And what I like about this is that there is a very clear separation of how the data flows through the application. But of course, I wouldn't actually want to write code like this way for two reasons. So one reason I wouldn't want to write it this way is just because I don't want to be writing code inside of a string. Like that doesn't make sense. I want to have like syntax highlighting. I want to have modules. I want to have type checking. So this is not really something that I would like use in production. And the other problem with this code is it's probably going to get very complex very fast. So if I keep layering on more features, even if I want to display this button multiple times, I will have to add a bunch of stuff here. I will have to add a bunch of stuff there. And I would have to somehow like connect them together. So wouldn't it be nice if we had some way to split like a function into other functions and like give them names that correspond to product features? Wouldn't it be nice if we had like a concept for this so that we wouldn't have to have this like single big function? So of course we have this concept, it's components. So maybe we can take a look at how code like this could look like in the component world. So we're just going to pluck some pieces out of it and see how it shapes up. So the first thing you do with the component is you give it a name. So I'm going to call this one cat name generator, because that's what it does. It's going to be, I'm going to need to export that, and it's going to be an async function. And I'm going to need this read file thing. And I don't need this URL part, so like I'm really kind of zooming in on like this particular part. So I won't need the body tag. Like I just want this kind of focus on the logic of cat name generator. And so it's pretty clear that I'm going to need all of these pieces. So I'm going to copy and paste this. And then I'm supposed to do something with them, but I'm not sure what yet. So I'll wait a little bit. And then let's have a look. What do we have here? So there's a bunch of HTML stuff that like seems kind of irrelevant. But then this reveal button, like that is definitely a part of what I want to render, and it has a click handler, and this click handler depends on some information actually. And one thing I want to do here is, so this information, this JSON, it's already known by the time any of this code in this inner world executes. So I can kind of pluck it out, and I can just put it here, because it doesn't matter. It's like available on load. And now that I kind of look at this, like I see here's like the input to this code, and it kind of looks like a React component with props. So I'm just going to put this as a prop here, and I'm going to copy and paste this event handler. Let's see, and I'm going to copy and paste this button. So this will be a button. This is JSX, it's not HTML, so I'm going to need to change the syntax a little bit. And I'm going to need to give this thing a name. So here it doesn't have a name. I'll just call it reveal button. And there's my button. So the next logical thing that I want to do is I just want to pass, I need to pass information from the thing in the outside to the thing in the inside. So I think it's natural to kind of think of this as, well, I just want to render a reveal button with cat name. So is that all, or did we forget something? I think we forgot something. What about all this green stuff? Like there's something there, right? Like there's some kind of a hard boundary that is dictated by the laws of physics. That is, these really are two completely separate worlds. Like this code could execute much, it could execute on a different computer, it could execute much earlier, and just like, the past me who prepared this talk and the present me who's given this talk cannot be in the same room at the same time, these two components cannot be in the same file. It breaks the laws of physics. So what do we do? One thing I'm going to do is I'm just going to embrace the fact that these are really two different programs in a way. These are two programs that execute in separate environments at different points in time. I really shouldn't think of them as a single thing, which sounds contradictory to what I was saying before, but there is some kind of a hard boundary between them. And so if I think of, these are completely separate programs, so like this program executes on the server, and if it imports something, then that will also be there. And then this is the stuff that executes in the browser. If it imports something, it will be there. Well, how do I pass information between them? So how do I pass information here? Like here, I kind of enter a string. There's like a place where I go from one world into another, and I can carry something with me. I can carry some data with me as I do that. And so what if there was a way to say, yeah, these are two separate programs, but you can open a door between them, and this door only works in one direction. It lets you pass things from the past into the future, and only things that can be turned into text or JSON or serialized can pass through them. So let's add a door. So this is the door. This is the green stuff. Like in Matrix, like when you're outside, you look at these green screens and you don't understand what's going on. But then when you're inside the Matrix, you kind of like, everything looks normal. So we've just entered the Matrix. So yeah, let's verify that this actually works. So I'm using Next.js here, but this example would work in any framework that supports React Server components. And I have the reveal button here. I press it, I see the result. And again, let's verify that it actually works like we expect. So I refresh the page, I press reveal. There is no extra network request because all the server part, it has already executed. And if we look at the HTML, there's a bunch of stuff here, but somewhere here there are props with the cat name. So this is the stuff that gets passed through the door. And so why would we want to do this? Well, one reason is that now that we think in components, we can do all the things that we can do with components. So we can nest them, we can render multiple of them, and each of those components can have these kind of points of handoff where we can pass information from one environment into another. So I'm not going to show that, but there will be plenty of talks today that kind of focus on these ideas. So do check them out. And I really want to just go back here for a moment and kind of just like recap what's going on. So we're used to thinking about the client and the server as two separate programs, but we can also think of like rendering a web page or rendering a UI as a single program that's split between two computers. And when we look at kind of vanilla JS representation, the way this works is that this part executes in the server world, and then it emits a program that will execute in the client world. And there is kind of like a hole through which we can pass information, but only things that are kind of can serialize to JSON can pass through that hole. And so the program is complete after both of these phases have run. And so if we look here in the React version, again we have the server, we have the part that lives in this world, and it can prepare a bunch of data, and then it can choose. There is a door here, so not every module would have a door, but if there is a door, this module is kind of saying, I can accept props from the server. I can accept props not just from above, but from capital letter above. Like I can accept props from the past, from another computer. It's like an information wormhole. Like this is kind of the second stage of this program. Like this is a program with two stages. One thing that's kind of interesting here is that actually, for practical reasons, on the server you want to run both stages because you want to generate the initial HTML. So you run this stage with the initial state, and then that gives you HTML. But then on the client, you might want to, this is the part that can update and re-render in response to state changes. So you kind of think of this as like, this is a program for two computers, and this is the first step, and this is how it says, this is what you're going to do next. And this is the code, and this is the data that this code needs without going back to the server so that it's available immediately. And this is really the door through which it passes, the door that allows to pass this kind of information. And so I have worked on this talk, and so that was the first phase of the process. And now I have given this talk, and this is the second phase of the process. And now the computation is complete. Thank you.